Hi everyone, in this video I am going to be solving this nice and easy problem that came up on a Hungarian math contest, I believe, many years ago. Here's what the problem says: prove that the product of 4 consecutive natural numbers cannot be the square of an integer. So the product of 4 consecutive natural numbers cannot be the square of an integer. That's what we have to prove. As always, give the video a pause and do try it out on your own before you go ahead and see how I am going to solve it. It's not very difficult, but it does require some work to be done. Okay, so as with any problem, let's start by investigating this situation with a simple set of numbers. So 4 consecutive natural numbers. So if we take our natural numbers as, let's say, 1, 2, 3 and 4 and multiply them, what do we get? We get 24, which is not a perfect square, but it is one less than a perfect square. Okay, now let me take another example: 2, 3, 4, 5. So what is this product? So 2 into 3 is 6, into 4 is 24, into 5 is 120. Again, not a perfect square, but interestingly, it is one less than a perfect square again. 121 is a perfect square, and one less than that is 120. Now, let's take another example: 3, 4, 5, 6. What is this product? So 3 into 4 is 12, into 5 is 60, into 6 is 360. And yet again, this is not a perfect square, but it is one less than a perfect square because 361 is a perfect square. So it seems from our investigation that if we multiply any 4 consecutive natural numbers, we are landing up at one less than a perfect square. And if we are able to prove that, then we will be done, because one less than a perfect square cannot be a perfect square itself. So that's what we have to do now. We have to prove that the product of any 4 consecutive natural numbers will be one less than a perfect square, and therefore it will not be a perfect square. So let me call my product P, and let me write my 4 consecutive natural numbers as n times n plus 1 times n plus 2 times n plus 3. Now, how do I go about proving that this expression, this product, is one less than a perfect square? For that, I have to do a little bit of algebraic manipulation, and I have to observe how these multipliers can be combined in various ways. And what I observe is that if I multiply this and this, and I write this as one pair, which is n times n plus 3, and then if I multiply this and this, and I write it as another pair, so n plus 1 times n plus 2, there is a certain advantage to doing this. Let me show you what that is. So n times n plus 3 is n square plus 3n, and n plus 1 times n plus 2 is, you have n square, 2n, and then n, and then 2. So this is n square plus 3n plus 2. And the advantage is that you are getting this expression n square plus 3n in both the terms, and that really makes our jobs easier now. Why is that? Because now I can actually think of this as a new term, and then I can prove that something into something plus 2 will not be a perfect square. But there is actually an even easier way to figure that out. So this is n square plus 3n, and this is the same thing plus 2. In the middle of these two numbers is n square plus 3n plus 1. So if I take this number n square plus 3n plus 1 as, let's say, a number k, k is in the middle of these two numbers, and if I take that number, then this first term is 1 less than k. It is simply k minus 1. And this number here is 1 more than k. So this is simply k plus 1, where k is n square plus 3n plus 1. And now this product is nothing but k square minus 1, and as expected, it is 1 less than a perfect square. So that completes our proof. Just by multiplying these out in this fashion, where we combine n and n plus 3 and n plus 1 and n plus 2, we are able to prove with this smart substitution of n square plus 3n plus 1 as a new integer k, that the product P is of the form k square minus 1. So, it will be 1 less than a perfect square, and therefore, the product of any 4 consecutive natural numbers can never be a perfect square. So, that concludes our proof. I hope you liked it. If you have an alternative that you might have used to solve this problem, do share it with me. I would love to know in the comments. Thank you.